Hi guys, I am Vignesh Ganesan from Kaliri.in e-learning platform. Now we are going to learn about kinetic log design. This is the overall motions of this kinetic log design part from this assembly of this area. Let's know each and every part. Start from its base positions. Select a top plane, create a new sketch, draw a circular profile with the diameter of 300 mm. From the center point, just to initiate a circular profile now, using a smart dimensions to fix this profile under 300 mm of dimensions. Exit the sketch and form a solid body using an extruded boss. Then the thickness is only 20 mm. Once it is drawn, then selecting the top face using a center point slot profile to draw two different profile or two different projections. One is an horizontal, another one is an vertical. First one is an vertical, next one is an horizontal. Hold your control button, selecting both the line profiles, then choose an equal to constants. Afterwards, just selecting a smart dimensions and fix this line with this vertical dimensions of 260 mm. Both profiles is gets equally fixed. Then the diameter, selecting both the one using equal to constraint again. Now choose the smart dimensions, then mentioning the horizontal dimensions value of 5 mm here. Exit the sketch right away. Now using this exact profiles, we are going to create a pocket. So selecting an extruded cut, choose it. Under selected counters area, we are going to prefer the exact portions of this. So right click, clear selection and choose this recommended portions one by one. Once it is selected, all these portions are getting removed now. The pocket is approached. Now selecting the stop face and create a new sketch, simply draw one center point circle. It is nothing but the diameter of 15 mm. Once it is mentioned, we are going to create a pocket by using of this diameter also. Yes, using through wall type to eliminate the entire portions. This is the entire portions gets completed. The initial base part is designed. Now the next one is hover hand. It is a simple, small kind of a body. So select a top line again, draw one vertical construction line, then mentioning with this dimensions of either 75 mm or 65 mm. I mentioned first is 75 mm. Now draw a circular profile, center point circle at two opposite positions, then mention it with the diameter value. First, the initial diameter is 2.5 mm, then the primary diameter is 20 mm. Let's draw a circle, angular line profile. Then fix this line with the tangential connection on both the circle. First, hold your control button, selecting this two opposite line and mate it with this tangential constraints. Again, mate it with the tangential constraints to this opposite area. Let's select this line and move it along the way. It is almost positioned at some of its area. Select this point and switch its location, then fix it tangentially. Using a trim entities to remove the excess number of these portions now. Using a trim entities, now I am just picking each of its every portions one by one and selecting the top excess number of these areas. Okay, let's draw two more circular profiles to create a pocket. Mention it within this same sketch profile itself using an equal to constraints. Now fix it with this vertical dimensions of 45 mm. Now what is the diameter value? It is 5 mm. Then exit the sketch to form a solid body under the thickness of 2.5 mm. The portion is created. The hover hand body is almost created. Next one is a connecting pin. Connecting pin is nothing but a simple profile. Selecting a top plane and create a new sketch, draw two opposite circular profile. One is on bottom one, that is from the origin point, another one is on top one. Fix it equally, then position it under the vertical dimensions of 45 mm. Afterwards, fix it with this diametrical value. It is 10 mm. The top point is not fixed within each other. Look at it, it is not positioned vertically. So, selecting both center points and fix it vertical constraints. Let's draw another circular profile and measure with the diametrical value of 5 mm. First, fix it equally using 5 mm of a dimensions and fix it with this value of Same 5 mm. Exit the sketch and form a solid body with this equal dimensions of only 3 mm. Select the same top plane again using a convert editors to project this edge into a sketch, both the top one as well as the bottom one. Once it is almost projected, then draw a center point rectangular profile. So, choose a center point rectangle, draw a profile vertically. Then fix this center point along with this origin. Choose an vertical constraints. Then the horizontal dimensions is nothing but 5 mm. Exit the sketch now and create an innermost solid portions using an extruded brush to choose this profile. Clear the selections and the thickness is nothing but 2.5 mm. Just to hide the sketch now, choose the fillet again and selecting this two opposite area. 4 different edges. The radius value is 10 mm. Connecting pin is created. Okay. Next one is a center spindle. It is also a simple revolvable solid body. So select our front plane now. Create a new sketch. Draw a L-shaped profiles. Vertical, horizontal, vertical, a complete stepped portions one by one. Now choose this particular point as well as hold your control button to fix it horizontally. Then fix it using a vertical center line. Fix with the center line. Choose the smart dimensions. The overall horizontal dimension is 30 mm. Then the secondary stepped dimensions overall diameter value is 15 mm. Then the vertical dimensions for this initial step is 10 mm. Then the secondary step is 5 mm. Now the innermost portion is a total of around 5 mm diameter. That is a small pocket to fix with a spin. Using a revolved brush to create a solid body. As the center spindle is almost created. Now the next one is angle rod. Let's get into select a top plane and create a new sketch. Draw a slot profile. Start point, end point. Again, start point, end point. Angularly draw on the profile now. Then choose two opposite line profiles and mention it equal constraints. Again, selecting this radius value as well as this opposite one to fix it with this equal radius. Then mention with this horizontal dimensions of 50 mm. Then fix it angularly also. The vertical diameter is 10 mm. Now fix it with this angular value. The angular value is 135 degree. It is nothing but a 45 mm of an angular slip positions. Once it is mentioned, then draw a 3 different circular profile with a diameter of 5 mm. First one, second one, then third one. Now hold your control. All 3 line profiles fix it equally. Then mention the diameter value of 5 mm. Exit. Then choose an extrude brush to create a solid part by selecting the required portions one by one. Then what is this thickness value? It is a 5 mm of thickness. For 5 mm of thickness, we can give a 3 mm of thickness value. So I mentioned 3 mm thickness for this angular pin. Okay. Now choose a fillet. Select this particular edges. Form a fillet under the radius of 5 mm. Okay. It's almost created. Here we draw on a different parts at different part category. But the main thing is assembly. Based on this assembly only, we can able to get the kinetic mechanisms from that. Now choose this particular solid, that is a part 1, base part. Once it is positions, right click and make it into a float part because we just fix it based on the origin point. So selecting each and every plane relate to that. First one is an right plane. Select a two opposite plane, fix it using and coincide constraints. Then selecting a front plane, both one to fix it using and coincide constraints. Then choose a top plane from the origin as well as some part profiles. Both the planes is almost fixed. The part is fixed at the center of its origin point area. Now inserting the secondary part. It is a spindle. Choose as made type. Select a two opposite concentric faces. Fix it. Then select the bottom of its faces and fix it to the top of its positions. OK. Again inserting a new component now. Here, hover hand is this part. Insert it on these positions. Then uses mate to fix it concentrically first. Selecting this cylindrical face as well as the cylindrical face from the center of its positions to fix it concentrically. Then select this bottom of its faces as well as this top faces to mate by using often coincide constraints. Now we are going to insert pins into the assembly area. Pin is just to handle the entire assembly and the motions. Open the part. What is the dimensions for this? The diameter is nothing but only 5 mm. Then extruded solid body up to the dimensions height of 25 mm. So the height is 25 mm now. Exit the sketch. Let's fix it tangentially on the slot position. So choose the mate, select the cylindrical faces, also the flat faces, mate it concentrically. Then choose this bottom of its faces now. Fix it using and coincide constraints. Again, just we need to create a new kind of a cylindrical body here. Let's create a duplicate part, same as like a previous one. Select a tangential mate to constrain it, same as like a previous one. First one, then the second one. Bottom face as well as this place to coincide. Okay. Let's use a angular pin or a connecting rod. I prefer this connecting rod. First, to make it concentrically on this primary positions and secondary positions. So select a two concentric faces to mate with each other. Then choose this bottom of its faces and fix it at this area. Choose this bottom of its faces as well as this top faces. Next, another concentric faces. Select two opposite concentric faces. It is almost made within each other. Now the primary one is angular pin. If you align it properly, almost we get the kinetic mechanisms. So select this primary angular pin part, insert it, then slightly rotate this part based on our recommended positions. So using rotate components, go to the top of its command manager, choose the rotate component to rotate it for our preferred angle. Once it is almost rotated, then choose a mate type, selecting this concentric type first for the two cylindrical faces mate within each other. Then choose the top faces as well as the top faces to mate it using coincide constraints. Let's duplicate the part again. Hold your control button, choose this particular components and drag it. The secondary part is duplicated now. Then choose a mate type. First select this concentric faces for a pin as well as this angular pin. Both one is selected. Then choose this common cylindrical faces. One is in this particular positions, then the another one. It is made angularly with each other. Then select this bottom of its faces as well as this bottom faces for this primary angular pin. Fix it using and coincide constraints. Okay, this is how it is gets now. Yes, almost we got that. Either we can use a mirror component to mirror these positions from a right hand to left hand. But if you mirror the component and change the positions, we cannot get the proper output. based on the selection of plane also. So instead of creating a or using a mirror component, using a same kind of a pass, twisting it and mate it properly. So first selecting this part, hold your control button, duplicating the part first. This is the actual angle pin, using the same kind of parts itself. Slightly rotate this component from our preferred positions. Then fix it tightly to the pin, same as like a previous one. First one is concentrically mate with this opposite one. Then selecting the top faces to mate it using a coincide constraints also. Select this particular one as well as this top one. Selecting both the faces, it is almost coincide within each other. Now choose this exact, again creating another duplicate part. This is the final one. Twisting this part. And using unmate, first to fix it concentrically. Okay. Now choose the secondary part, that is the secondary cylindrical positions. Two opposite faces is made within each other, selecting this bottom of its faces as well as this back face to mate it using a coincide constraints. Okay, almost we get that. Next thing is form a pattern now. Now choose a circular component pattern, select a 4 different angular pin. Also prefer the circular edges as a reference, increasing the number of instance into 4. The 4 different components is created. Then use this mate type and choose the 2 opposite cylindrical faces to mate it concentrically. Okay, once it is almost made with each other, then fix this rest of the components also. Almost we get the kinetic mechanism now. Instead of creating an additional or rotating this entire hover hand, before that go back to the circular component pattern and selecting the pins also to create a circular patterns. It is projected on these 4 different directions. Let's form a mechanism. By rotating the component, you almost get that. Look at it, how it is elegant now. Simply fix it using a standard mate to fix this entire portions and creating a number of the patterns. We achieve this kind of a solid mechanisms. Thank you for that.